All right, we're working on chapter 4, and we're doing logarithms and exponential functions. We're going to start off with finishing some topics on exponential functions. Number 1, use a calculator. So use whatever calculator you have. Here's the exponential function, 542 times 1.03 to the x, and it models the population of a country x years after 1969. Substitute 0 in for x here. So a lot of this is just doing stuff by the calculator. So put this in the calculator, plug in 0 for x, you get 542. You want to know the population in 1991. That is 22 years after 1969. So you put in 22 in for x, 542 times 1.032 raised to the 22nd power is about 1,083 million people. Okay, and then you just work your way through the rest of them. So let's see if they're asking you to round. To the nearest million. So if you're rounding to the nearest million, it's 84 for me. 84. And then you just roll through the same way. In 2013, that's 44 years. So in the calculator, that's about 2,167 million. Rounding correctly. And then if you put in for 2035, that's 66 years. That's 4,300. I'm sorry, 4,334. And so it looks like from year to year to year, it looks like that the population every 22 years, it looks like the population is doubling. And so it appears that the population is growing by a factor of 2 every 22 years. The next question is similar to that. You've been given a formula that represents the amount of kilograms of a radioactive element in the atmosphere. It's modeled by this function. So that was in 1985, and so we want to know about what happens in 2025. That's 40 years. And so if it says if even 100 kilograms remains, the area is considered unsafe. When you plug in 40, you get 1,000 times 0.5 to the 4 divided by 3 is about 396.9, which is more than 100 kilograms. And so it's still unsafe. So will the area be safe? The answer is no, because there will still be more than 100 kilograms left in the atmosphere. Then with number 3, we started talking about logs. And so when I write y is equal to log base b of x, the definition means that b to the y power is equal to x. B to the y equals x. That's what it means. That's the definition. So that the log is the power, right? And so the question is, what power do you raise b to in order to get b? And b to the first is equal to b. So the log of b to base b is 1. log base b of b is equal to 1. The power you need to raise b to get b to the x is x. B to the x is equal to b to the x because it's the power. And b and log base b of x, they cancel, leaving you with only x. So b to log base b of anything is just that thing. The domain of the log is 0 to infinity, and the range is minus infinity to infinity. If you have a log and there is no, and the base is 10, then we call it the common log function, and on your calculator it just looks like log, and we just write it with no base. So log base 10 of x is usually written without a base. If the base is e, which is a special number, then we call it the natural log, and here's the notation for it. Now we wrote earlier that log base, if y is equal to log base b of x, then that means that b to the y is equal to x, and so this is called log form, and this is called exponential form. Right? So the base is b, the power is y, and this is 9. So again, the log is the power, so the power always goes here. So the log is the power, the base is 3, and 9. And again, the way that you can check is that 3 to the second is equal to 9. That's how you know it's right. So log base 3 of 9 is equal to 2. That is what you put in. Here, log base, the base here is 3 of 1 over 27 equals negative 3. Again, filling this in, log base blank of blank equals blank. Again, the exponent always goes over here. Exponent goes there. 3 is the base as well, so the base goes here. And then x is whatever's on the other side of the equal sign. And again, the way that you can check, 3 to the third is equal to x. That's how you know it's right. $14, you need to know, we want to know what this number is. And so all this is the power of 3's to get 729. And so 3 times 3 is 9. 9 times 3 equals 27. 27 times 3 is 81. 81 times 3 equals 243. 243 times 3 is 729. So what we've just learned is that 3 to the 1, 2, 3, 4, 5, 6. 3 to the 6 is 729. So 6 is the power you need to raise 3 to in order to get 729, and therefore the answer is 6, because the logarithm is the power you need to raise 3 to in order to get 729. Now, as we progress in these, we're just going to be saying things about the power. And here is another remark about the power. And it's that negative powers are fractions. And so 10 to the first is 10. 10 to the second is 100. But if I wrote 10 to the minus second, that's 1 over 100. Right? So the negative makes it a fraction. So you do 1 over 10 to the second. And so for this reason, 10 to the minus first is 1 over 10 to the first. And so negative 1 is the power that you raise 10 to get 1 over 10, and therefore the answer is negative 1. The remark here is that the square root of x is x to the 1/2. So in other words, the square root is the 1/2 power. And therefore, 6 to the 1/2 power is the square root of x. Now, combining the two things that we just said, that if I know that to get a square root, I need to raise 7 to the 1/2 power. Right? So the square root is the 1/2 power. And when you flip is the negative 1 power, then putting these together is the negative 1/2 power to get 1 over the square root of 7. The log of 100, well, the base is 10. If you don't see a base, the base is 10. Right, so no base is assumed 10. And then we ask ourselves, what power? 10 squared is 100. And so 2 is the power you need to raise 10 to in order to get 100. So the log is that exponent. Here, log base 10 to 10 to the 8th again. What power do you raise 10 to get 10 to the 8th? That number is 8, because 10 to the 8th is 10 to the 8th. From what we said earlier, that 10 and log base 10, they cancel. The answer is 37. They just cancel. For the same reason, natural log is log base e of e to the 4th. And again, these things just cancel out, and the answer is 4. For the same reason here, they cancel out. The answer is 131. This one here, we're going to use some properties. Log base 9 of 9. We said earlier that log base b of b is 1. So log base 9 of 9 is also 1. And so log base 2 of log base 9 of 9 is log base 2 of 1. And now the question is, what power do you raise 2 to get 1? And the answer to that is 0. 2 to the 0 is 1. So the answer to this is 0. Log base 9 of 9 is 1, because 9 to the first is 9. The log of 1, and in general, the log base b of 1 is always 0. So the log of 1 is always 0, because 10 to the 0 is equal to 1. Hope it helps, and I will see you soon.